So one thing we need to make very clear up front is the difference between declarations and definitions. Okay? If you're coming from Java, you should already know this difference. Okay? You need to declare something before you define it. What that means is a declaration is saying like int I. A definition is like saying I equals 2. When you declare something, you're just declaring you've got a variable, and it's going to exist in memory. You're not actually defining the memory at this point. When you define something, you define the memory. Okay? So you declare something to be of a certain type, but then when you define it, it's where the memory gets allocated. Okay? So in C++, you can declare stuff multiple times. I can say int I semicolon. I can say int I semicolon again. Okay, actually, I don't know if this will compile, but it hopefully will. Particularly more happens to functions. I can declare functions multiple times. But I can only define it once. If I go to define it in some other place, so particular functions, if I go to define them twice, then I'll get an error message. Okay? So some slides there on what that all means. Okay? There's a key point there about the extern keyword. Okay? It allows you to declare a variable without defining it. Okay? Generally, you don't use that. Okay? But there's some particular strange reasons why you use it, including multiple files from different locations and things like that. Again, textbook goes into far more detail, but for now, just store that in the back of your mind. So, declarations. Declarations have a name and a type. Okay? And it tells the compiler what this thing is going to be some point in the future. Okay? So you can declare a thing like an int. You go int error number. You can do what's called a type def declaration. Okay? So my int is an int, and that basically works as an alias. So my int is now the same as an int. It substitutes that word in. You can declare a function. You can declare a class. And you can declare a template. Okay? And generally, all these things go in header files. Okay? Generally, not always. Then you can define these things. So to define these things is like saying error number equals 20. Okay? Now you've defined it. Okay? And so we've got the separation of these things called an entity, which is the declaration, and the definition. Okay? So the entity is the memory allocated, and you define it by allocating memory. The type def here is an int, and then my int is a synonym or an alias for int. You've got a function here, okay? The definition is between the braces here, okay? And it defines the function. Again, with class, you define the data members between the braces of the function definition. Also, the class definition. Okay? Every name, so every declaration must happen before it's defined, must happen before it's used. And you can only define something once. Okay? So you can declare things multiple times, but you can only define something once. Okay? So separating out declarations and definitions is basically being able to use header files. Okay? And there's a very good example of this, hopefully on the next slide. Yeah, here you go. So if we have some code here, and I'm going to look at the middle. So user.cpp, okay? User.cpp includes this file called thirdparty.h. Thirdparty.h defines a function called doit. And also, it's probably quite dumb, but it defines a variable called count. Okay? Your thirdparty.cpp, which also includes thirdparty.h and compiles to this .o file we talked about an hour ago, okay, defines what count is, so count's equal to 1, and defines the function doit. Okay? This thirdparty.cpp is compiled to a .o file, so say a thirdparty.o file. Okay? User.cpp only hash includes the thirdparty.h. It doesn't hash include thirdparty.cpp. You do not need the thirdparty.cpp file in order to compile this program. What you need is you need thirdparty.h, and that will compile it. To link it, you then need thirdparty.o. Okay? And then that will link and turn it into an actual application. I actually don't have the source code for this sitting as some demos. I probably should. I'll see if by Thursday, will make this into some demos to show you. Okay? So what this also means is if I wanted to distribute some libraries other people can use, but I didn't want to give my code away, okay? Say if I didn't believe in open source, I wanted to keep things closed source, I can pass around for .o files. So in Windows, these are often .dll files, dynamic link libraries, okay? So think of .os and .dlls, they're the same thing. There are a series of compiled libraries that you compile your code against or link your code against. That is what this separation allows me to do. Okay. So header files, okay? Header files allow us to do this. They should contain logically related declarations, so things that are going to work within your library. They should generally not include definitions. Okay? The reason why I say generally is you can put definitions in your header files all you like. It's a really bad style though, and it can cause big problems. Okay? The reason why it says generally is when we come to talking about templates, you have to put all your definitions inside for template code, which actually goes in your header file. We'll worry about that in a few weeks' time. And importantly, to save problems with compilation, you need this thing called header guards. Now, what header guards do is at the bottom part of this slide here. They say to a preprocessor, they say, if you haven't already defined this set of code, here's a whole ton of definitions or declarations for this set of code. Okay? They protect your code from having problems with multiple inclusions. What this means is if I've got a file, file1.cpp, and that hash includes my header.h, and it declares and defines a whole ton of stuff, and I've got a separate file called myfile2.cpp, and it also hash includes the same file, if I don't have header guards on that, what happens is that file gets copied into file1.cpp, that gets copied into file2.cpp. You go to compile it and it says, oh, it's been multiple declared. It's been declared in two different places. Header guards prevent that. Header guards say, only define this once. Okay? Now, you've got other things to do with preprocessors like hash include, hash define, etc. Okay? But just be aware of header guards. You should just get in practice of always using them. Again, good place to go to check out more information about that is the Google Style Guide. So, again, what's typically found in a header file, class declarations. You'll sometimes find class definitions inside header files. Templates, okay, we'll worry about templates later on. These functions called inline functions, we'll worry about that on Thursday. Here's a function declaration, integer declaration. You might define, this is interesting, a thing called const double pi, okay? What this const does, and we'll get to it, it declares something to be constant that can't be changed. Okay, so we might actually put that definition up inside a header file because it's not going to get changed, so it's fine sitting there. We might define an enumerator type there. You might put one of these type defs here. By the way, never write code that looks like that because I've got no idea what that says. Okay, and a header file can hash include other header files. Okay, so be aware of that. Header file can hash include other header files. Again, we'll clear it up probably on Thursday, but do not put using namespace standard into a header file. Okay? If you already know some C++, do not put using namespace standard into a header file. It will cause you a world of pain. Okay? So what can't be put in a header file? We'll see this int I equals 1 here. Don't do that because this is my example it's given with file 1 and file 2, both including this .h. It ends up being declared twice. Okay? Don't put the definition of a function inside a header file. So void if semicolon there should be fine, but the definition of what goes in the if causes you problems. Okay? So don't put, again, separate declarations and definitions. Okay? So there's actually a rule for this. It's called the one definition rule, which is to do with defining something once. Okay? So this can have problems, okay? But you can go and do these things. So for argument's sake here, we define a function, or declare a function called int f, takes an int. It's actually never defined. But we never use it, so the compiler's actually fine with this. Okay? Again, bad style, don't do this. But you can do these things about, all these things will compile fine, even though they're not defined. So the function up here, okay, we've declared it, we haven't defined it, but it doesn't get called, so it's fine. The extern int I, it's expected to be defined somewhere else, so it compiles fine. The class stack here compiles fine, even though it gets used here, because again, we're doing the declaration, we're not doing the definition. So we've declared that we have a pointer to a stack, but we haven't defined it in memory. Okay? And because inside that main there's still only a declaration or definition, it compiles fine. Okay? You can break the one definition rule and cause yourself pain by doing this. Here's some ways in which you can do it. So, file 1 and file 2, both CPP files. Both have a definition of a class called point. Okay? One has int x and int y, one has int a and int b. Both of these files compile. Okay? All of this stuff compiles. When it comes to linking, so this idea that I need to link file 1 and file 2 together, that's where they cause problems. It's because the computer really doesn't care that this is x and this is y. It only cares that you've got two ints there. And you've got two ints there, and therefore they're the same thing. Okay? So that's why these things should be defined up inside a .h file correctly. And actually, glancing at these slides, be aware there's missing semicolons on the end of y. That isn't deliberate. So int x and y should be fine. Int x char y, that will also compile fine, but then when you go to link it, we'll go, well, this class point over here has two ints, and this class point over here is an int and a char. That doesn't make any sense. Okay? So you've got to be aware of these things. And so, again, using header guards, using hash includes, declaring stuff correctly under good naming conventions is ways of avoiding these problems. Okay. Okay, so let's talk about pointers.